I welcome you all to the session of engine system and performance, and in today's lecture we shall briefly discuss about what is engine system, and then we shall discuss about the subsystem or subsystems, those work together to have some stated objectives of an engine. So, if we try to recall the definition of any mechanical system, by this time you have read a few subjects. What is a mechanical system? So, if we try to write the concept of a mechanical system, like the definition of any system, we also can define a mechanical system wherein a few items will work together to give some output, maybe at the cost of some energy exchange. So, if we try to write the definition, that what is the definition? A few items or components work together to deliver some output depending on the requirement at the cost of energy or motion exchange. So, this is the definition of a mechanical system. So, now if we try to apply this concept to an engine system, what we can understand, we can conceive that there will be a few components, subsystems. Those components or subsystem will work together to deliver some output, certainly at the cost of some energy. If we try to recall our understanding on thermodynamics, the energy would be in terms of heat, and pertaining to the definition of engine system, at the cost of some input energy in the form of heat, we are expecting or will expect to have some output, energy output in the form of work. So, we can see from the schematic depiction that a few items or component are there. Those components or item will work together to have some output from this engine, certainly at the cost of some input energy. Now, let us get into those systems, subsystems rather. Let us look into these components or items, and you can see that this schematic depiction is specific to a spark ignition engine, because you can see the spark plug that is shown over here. So, the spark plug is also an important or essential component for SI engines, and starting with the spark plug or this essential component, we can have several subsystems of an engine. So, if we try to write engine system, then following the definition that we have discussed few minutes back, all these components together form an engine system. the sole purpose of this engine system is to have some output at the cost of some input energy. Now, if we eliminate this component and if we can have one fuel injection system or fuel injector or fuel nozzle, then the schematic depiction will be used to define or used to signify a compression ignition engine. So, whether the engine system will be having a spark plug or it will be having a fuel injection system, the engine nomenclature will be changed. So, the spark plug is responsible for the initiation of spark, which in turn will be used to combust the fuel air mixture or fuel, from where we will be getting some energy in the form of heat, and that heat would be converted into useful work, and that is what is the purpose of having this system. So, now in this engine system typically there are 3 subsystems. The first subsystem is that is called ignition system. This ignition system is applicable for spark ignition engines, or equivalently we can write fuel injection system for the CI engines. Since we did not classify engines until now, we are trying to have generic expression or generic subsystems. So, this is the ignition system. Ignition system is for the SI engines. Similarly, fuel injection system will be there, fuel injection subsystem will be there for the CI engines. Then second, so this is one. Second is lubrication system. And you can see that why lubrication system is needed, because you can understand from the schematic depiction that this engine is having one cylinder, that is this. Also there is a piston, and that piston will be having a reciprocating movement between these two location. One is top dead center, another one is bottom dead center. So, the piston will be inside the engine cylinder, and the piston will be having continuous reciprocating motion between these two locations, and that reciprocating motion would be converted using another mechanical subsystem, will be converted using another mechanical system into the rotary motion, and using that rotary motion wheel will rotate and we can traverse or travel a distance. So, this piston is inside the engine cylinder. So, this piston will be having always in contact with the cylinder wall. So, these two components, mating components. So, out of these two mating components there is a relative motion of the piston. So, to prevent several mechanical issues, to I should say minimize several losses, we need to supply lubrication, or we need to have lubrication system. We need to supply lubricants, and that is why this lubrication system is important. The last one is the cooling system. What is cooling system? You can still see from the schematic depiction that there is a cooling water jacket, that is also shown over here. What is the purpose of this particular item or component? Because whether the engine is a SI engine or CI engine, we need to have some sort of combustion. Depending on the type of the engine, combustion will be different, and it is because of this combustion there will be huge generation of heat, energy in the form of heat, because the reaction that would be there inside is an exothermic reaction. And you all know from an exothermic reaction heat would be liberated, and that heat will essentially allow to have this reciprocating motion of the piston. Now, the question is that heat, is it possible to utilize the whole heat that will produce because of this combustion into the equivalent amount of work? No, because that is what we have learned from our basic thermodynamics. So, certainly certain amount of heat needs to be transferred from the combustion chamber into the ambience through the cylinder wall. So, that means if we do not have enough provision for the transport of heat which will be developed or generated inside the combustion chamber into the ambience, that heat will again lead to several other mechanical issues like development of a crack, the engine cylinder might get might break. So, all these detrimental issues, detrimental effects will be there. So, to prevent all these mechanical abnormalities or mechanical issues, we need to supply coolant to minimize or to reduce the or to enhance the heat transfer. So, that is why this cooling system will be there. So, these three are the major subsystems what we can see from the schematic depiction. There are many other components, sub-components, but these three systems are the main systems which are needed for an engine for its best performance or operational. Now, let us quickly revisit what is the need of an ignition system or lubrication system and cooling system. The question is, as I told you, say for example, if we pick up this particular system or subsystem, what we can see, we have understood that we need to supply coolant, maybe water if it is liquid coolant, or maybe air if it is air cooled engine. If it is water cooled engine, we need to supply water. If it is air cooled engine, we need to supply air. Whatever the case may be, we are supplying, say for example, water to reduce the temperature or to take certain amount of heat away from the engine cylinder. Now, we really do not know what should be the amount of water circulated. So, that information nowadays must come from state of the art sensors. So, that part we will discuss, whether what is the amount of water needs to be circulated through this cooling water jacket, what is the temperature should be taken away from the engine cylinder, because there is again an important aspect. If we supply more amount of water through this cooling water jacket or into this cooling water jacket, that water will take away substantial amount of heat from the engine cylinder. If it is the case, so that heat, instead of doing certain amount of work, will be lost. So, that should not be the design criteria. So, all these aspects are taken into account nowadays using state of the art sensors. That part we will discuss in our subsequent lectures. Okay. So, if we now go into this ignition system, just for the sake of completeness, ignition system, what is the requirement? Requirement is supply minimum energy. Number 2 is initiate combustion. And number 3 is to establish, to supply, to initiate, to establish flame under all operating condition. Right. So, if we go back to the previous slide, as you can see that spark plug is there, that element is responsible to initiate spark, and that spark is essentially will help, the spark will essentially help to initiate combustion. And so, we should have a system that or subsystem, that subsystem would be responsible to initiate spark at a proper time. It will, that spark will initiate combustion at a perfect time, and that combustion, what is combustion? Combustion is basically, you know, that is a very complicated process. You need to understand so many, you know, fundamental subjects like fluid mechanics, heat transfer, thermodynamics. So, you know, cursorily I can say that combustion is nothing but the appearance of a visible flame. So, when the flame will produce, we will understand that combustion has initiated, and that flame should traverse or travel across the engine cylinder. So, that means the flame will produce because of this combustion, and that flame will be there under all operating condition. We can ensure all these three using a system, that is the ignition system. So, these are the requirements for an ignition system, right. Now, then what are the functions? So, if we write the functions, right. So, function is, so as you had seen that spark plug is there. So, ignition system, in an ignition system or subsystem, spark plug is an integral component. So, the spark plug will be there and it will produce, you know, high voltage spark, you know, across the spark plug. Okay. Then number 2 is, not only it will produce, so basically we are talking about spark plug now, because spark plug is an integral component of an ignition system. So, then to know about the functions of an ignition system, we must know about the function of a spark plug. So, it will produce high voltage spark, but not only it will produce high voltage spark, but also it will distribute high voltage spark to each spark plug. Because an engine might have multiple spark plugs. This is thing, and then, so this is 1, this is 2, we can write 3, that it will ensure spark to occur at, you know, a proper time. What does it mean? That means exactly when, I hope you have read internal combustion engine. So, pertaining to spark ignition engine, actual combustion starts when piston is reaching towards TDC from BDC, and when piston is about to reach at TDC, this spark will occur. So, that is the concept. And the most important function is, it will allow to vary spark timing with load, because it is not, or it will not be a case always that the engine will operate, you know, at a design condition. Engine might have to, you know, bear additional load. In that case, the spark plug, the system should allow to vary the spark timing depending on the load being expected from the engine. So, these are the ignition system. Now, having discussed all these, that is the requirement of an ignition system, which is essentially for the spark plug, and then the functionalities of an ignition system. Let us now briefly revisit what are the different types of ignition system. So, different types of ignition system. Though you have read all these in detail in your internal combustion engine course undergraduate level, but still as I said, for the sake of completeness I am trying to revisit all these. So, the first one is, so different types are battery coil type, Magneto type, number 3 is electronically controlled. Electronically controlled, still it can be subclassified into two different categories. The first one is transistorized coil ignition, and second one is capacitor discharge ignition. So, these three are the three different types of ignition system typically used in SI engine. We all know about all this battery coil type, magneto type, electronically controlled type, which is again can be subclassified into two different categories. So, let us now briefly discuss about the common types. So, the most common type which is used in internal combustion engine is the battery coil. So, this is the most common type. So, let us now discuss about this particular type, about the kind of advantage and disadvantage. So, if we write battery coil type, I will draw the schematic depiction of this coil type. Let us first discuss about what are the components. So, components are, certainly you can understand battery will be there, right, ignition switch will be there, then ignition coil will be there, then switching device, then spark plug, and then ignition system wiring. So, all these components are there for a battery coil type. Let us briefly kind of draw the schematic depiction of this particular type. So, let us draw the schematic depiction of this particular type. Schematically I am trying to illustrate or demonstrate several components. So, this is the battery, then from battery we will be having one ignition switch, then we have one ignition coil, so this is ignition coil. Then from this ignition coil, this spark will develop and that spark will go to the spark plug, and so from there we will be getting electronic arc. So, this is electronic arc, and this switching device will be there. So, this is switching device. This is the spark plug, okay, and this is spark plug wire. Okay. Now, and this is basically ignition switch. So, this is ignition switch. So, this is the schematic depiction of a battery coil type. You can understand exactly what are the components I have written over here are there in this schematic depiction. Okay. So, I am not going to discuss in detail about the functionalities of this, because you have read this basic the basic principle of this particular circuit. So, the idea is that this entire purpose is to produce electronic arc, and that spark will initiate combustion. So, if we go back to the previous slide, there are several other types also. So, certainly though battery coil type is the most common type, but still since there are several other types, certainly this type is also having certain disadvantages. So, we should know all these. So, what are the advantage of battery coil type? Of battery coil type. Advantages are: number one is cheap as compared to the types we have discussed today. Number two is provide spark at both at high and low speed. Number three is maintenance is negligible except for battery, right, and that is why it can be used in cars or buses. But despite all these advantages, there are certain disadvantages as well, and it is because of these disadvantages several other types emerged. So, disadvantages are, this is number one is heavy and bulky. So, takes more space. So, occupies more space. More space. Number 2 is, when engine speed increases, spark strength drops. Number 3 is, if battery is discharged completely, not completely even, if battery is discharged, engine cannot be started. It is not necessary that battery has to be discharged completely, but even when battery is partially discharged, very difficult to start the engine. So, having despite all these favorable aspects, we are still having a few drawbacks, and it is because of this reason two different other types, that is magneto type and electronically controlled type are there in place, which are also used for the engine. I am not going to discuss about again the advantage and disadvantage of magneto type, but certainly you can understand that since we could identify all these drawbacks associated with a battery coil type ignition system, the idea should be to eliminate all these issues using another system, that is the magneto type or another type. So, the magneto type will not be having all these issues. So, if I just write the very quickly that magneto type, and let me write the advantage. Right. Again, number 1 is less maintenance, number 2 is light in weight, that is not heavy or bulky. So, space and occupies less space. As I told you that we had seen that it is heavy and bulky, so occupies more space. So, certainly we should design for another type, and in that particular type we can eliminate this particular problem or issue. So, that is this, and number 3 is provides high intensity spark at high speed. And number 4 is used in two-wheelers, right, or and aeroplanes. So, these are the kind of favorable part of this particular type, but since this is again a mechanical subsystem, it will be having a few other drawbacks. So, what are the drawbacks? Disadvantages. I did not draw the schematic depiction, but you know that magneto type is, so we need to have some magnets, permanent magnet, and some magnetic current will produce. So, when the current will flow, when wiring carry high voltage current, high voltage current, there is a possibility of leakage, thus causing misfiring. So, this is number 1, and number 2 is, since there is a possibility of having leakage of current causing misfiring, so the shielding would be there and that shielding is expensive. So, I am writing here expensive shielding is needed to prevent leakage, current leakage, right. So, if we summarize today's discussion, we can see that we have discussed about the engine system, starting from the definition of a mechanical system. We also could define the engine system. In engine system, there are several subsystems. We have identified 3 major subsystems. We have discussed about an important subsystem today and several types, their advantages and also disadvantages. In the next class, we shall discuss about the remaining other 2 subsystems, that is cooling system and lubrication system. We shall discuss about the need of having these 2 systems together with different types, and then we shall discuss that to operate all these subsystems, as I have briefly mentioned today in the beginning of today's lecture, that we need to resort several state of the art electronic circuit or sensors, so that all these systems or subsystems can perform efficiently to enable the engine system to run smoothly. So, with this I stop here today and we shall continue our discussion in the next class. Thank you.